Okay, let us have more of the secondary indeterminate forms. And in this lesson, we would be looking into limits of expressions that initially would result to one of the secondary power forms, namely 0 raised to 0, infinity raised to 0, or 1 raised to infinity. So that at the end of this lesson, you should be able to apply L'Hopital's rule again to be able to evaluate the limit of such expressions. Again, let us recall the indeterminate power forms. 0 raised to 0, infinity raised to 0, or 1 raised to infinity. So let us consider having two functions, f of x and g of x. If the limit of f of x as x approaches a is 0, and the limit of g of x as x approaches a is 0, or if the limit of f of x as x approaches a increases without bound positively, and that the limit of g of x as x approaches a is 0, or the case of having the limit of f of x as x approaches a is 1, or the limit of g of x as x approaches a is increasing without bound, then the expression the limit of f of x raised to g of x as x approaches a would assume one of the indeterminate power forms. You have 0 raised to 0, infinity raised to 0, or 1 raised to infinity, respectively. Okay, whenever the expression the limit of f of x raised to g of x as x approaches a assume one of the indeterminate power forms, 0 raised to 0, infinity raised to 0, or 1 raised to infinity, then the limit of the function f of x raised to g of x may be evaluated by doing the following steps. First is that the function f of x raised to g of x is represented by a variable y, or by some other variable of your choice. And then with this, the limit of f of x raised to g of x as x approaches a is equal to the limit of y as x approaches a, and that this will be evaluated indirectly by first evaluating the limit of ln of f of x raised to g of x as x approaches a, or we have the limit of ln y as x approaches a. Now, using properties of the logarithms, the function ln y can now be transformed into a product and then further transformed into a fraction where the limit would be either a 0 over 0 or an infinity over infinity. In which case, we can now make use of L'Hopital's rule to evaluate the limit. Okay, let us work out the procedure applying it to evaluating the limit of x raised to 1 over x minus 1 as x approaches 1 from the right. So, if you will investigate initially what the limit of the given power is as x approaches 1 from the right, this would lead us to having 1 raised to 1 over 1 minus 1, or we have 1 raised to 1 divided by 0, or we have 1 raised to an undefined value approaching positive infinity. Okay, so as the procedure dictates, the first thing that you do is you let the power x raised to 1 over x minus 1 be represented by the variable y, or you may use some other variable of your choice. Then let us make use of the properties of the logarithms so that we work on the natural log of y, and that would equal the natural log of the power x raised to 1 over x minus 1. And using the property of the logarithms that states that the logarithm of a power a to the b would be equal to the exponent b times the logarithm of the base. Therefore, the natural log of x to the 1 over x minus 1 will now be equal to the exponent 1 over x minus 1 times the logarithm of the base x. Or you can express this as a ratio or a fraction where you have ln x divided by x minus 1. So, at this point, we have ln y equal to ln x divided by x minus 1. And if you will investigate what the limit of ln y would be as x approaches 1 from the right, this will be given by the limit of ln x divided by x minus 1 as x approaches from the right. Or we will have ln 1 divided by 1 minus 1, giving us a 0 divided by 0. Okay, so at this point we encounter an indeterminate form 0 over 0. And as such, we now can use L'Hopital's rule to evaluate the limit of ln y or the limit of ln x divided by x minus 1 as x approaches 1 from the right. Okay, so the application of L'Hopital's rule will now give us the limit in terms of the limit as x approaches 1 from the right of the derivative of ln x divided by the derivative of x minus 1. And that the derivative of ln x is just 1 over x. And that of x minus 1 is a 1. So we now have to evaluate the limit of 1 divided by x all over 1 as x approaches 1 from the right. Or simply, evaluating the limit of 1 over x as x approaches 1 from the right, giving us a 1. So with this, 1 is found the limit of ln, or the limit of 1 over x as x approaches 1 from the right, which is also the limit of ln x divided by x minus 1 as x approaches 1 from the right by L'Hopital's rule. Or we say that is the limit of ln y as x approaches 1 from the right. So on this basis, we now can work on what the limit of y or the limit of x raised to 1 over x minus 1 would be by working on the inverse function of ln y, which is said to be equal to 1. Okay, and that the inverse function would be defined by e to the ln y is equal to e to the first power, and by some properties of the logarithm and the exponential function, e to the ln y we just simplify to a y. So this statement now simply is y equal to e. So what we're saying is that the limit of y as x approaches 1 from the right, which is found to be equal to e, would also be the limit of x raised to 1 over x minus 1 as x approaches 1 from the right. Okay, that would be equal to e, which is approximately equal to 2.71. So when we are given an expression f of x raised to g of x, whose limit as x approaches a assumes one of the secondary power forms, the 0 raised to 0, infinity raised to 0, or 1 raised to infinity, then evaluating the limit of the said expression would be done indirectly by evaluating the limit of ln y, where ln y is defined ln of f of x raised to g of x, okay, which also can be written as g of x times ln of f of x, or in terms of a fraction, is ln of f of x divided by the reciprocal of g of x. So that when you have written ln of y in this form, investigating the limit as x approaches a may result to either a 0 over 0 or an infinity over infinity, on which case we can now apply L'Hopital's rule to evaluate the limit. Okay, so I hope with this lesson you will be able to evaluate limits of powers that could be initially giving you one of the indeterminate power forms. I'll see you in the next lesson.